Hello Year 2 parents, I'm Miss Holiday and I'm going to talk to you a bit more about what we do in Year 2 when we're teaching maths. I thought I'd start with this grid to begin with because it's a really important grid that we use a lot when we're teaching addition and subtraction. You should have seen this before, hopefully, and you should have received a copy at Parents' Evening of this grid. If you've lost it or you haven't seen it before, please ask your class teacher for a copy because it's really important. It's a really good tool to use at home for some quick fire maths. Okay, so we've been focusing on the Year 1 facts in the autumn term because we really wanted to make sure the children were really confident with those facts and they knew them really well so they could apply those to larger numbers. Now you can see here inside the staircase part is the Year 2 facts, so we're moving on to those facts now. Really, you can see down here we've got the doubles and we're focusing on the larger doubles, and we're always looking at patterns so we know that the total when we're doubling is going to be an even number. We also look at near doubles because if we know 6 adds 6 equals 12, we know what 6 adds 7 equals. It's just going to be one more, it's going to be 13. So we're really trying to train the children to use the facts that they already know to help them with other facts. So they know their doubles really well, they can do it quickly, so it's just adding one more. So trying to move away from counting on their fingers as much. We also really focus on, they really focus on this in Year 1, and we also really focus on it in Year 2 because it's so important, is the number ones to 10, because the number ones to 10, it helps the children to bridge 10. So I'll be moving on to that later on in the presentation anyway. So they're really important to make sure that they're confident with those and they can recall them quickly. Another thing we do is we're doing 9 add 5, for instance. We're adding a number to 9. We know that 9 add 1 more equals 10. So if we're doing 9 add 5, we can think of it as 10 add 5 equals 15, but it can't be 15 because it's 9 add 5. So we're just taking 1 off, it's 14 because we used 1 from the 5 to reach the 10. So we do things like that. We also go on and on about the fact that when we're adding, it's commutative. So if we know what 3 add 4 equals, we're going to know what 4 add 3 equals. So that really helps us know a lot more facts than we did before. Okay, so this is what I was kind of thinking about that we use small numbers a lot to help us inform and help our maths when we're dealing with larger numbers. So if you know any fact within 10, you will know your facts within 20 or 30 or 40. So 6 minus 1 equals 5. So you can see that pictorially in what we call a tens frame. We also use the concrete versions of tens frames in the class as well. They're really easy to use. You can take them out if you're not using certain ones. You can turn them over so they're yellow, so they're different colour, so they stand out more. Okay, so we use these a lot, and the pictorial alongside as well as the abstract. So they're not just doing concrete, then pictorial, then abstract. They're more interlinked, and it's more to help reinforce something they already know. So if we know 6 minus 1 equals 5, you can see it clearly in a tens frame, and then you can see it clearly how that's going to be related to larger facts. So I know that 6 minus 1 equals 5. Then so 16 minus 1 equals 15. You can see the similarity here, and just you've got an extra 10. So that makes it easier to, if you spot those patterns, you can apply that within your number to help you with those number sentences. Again, if you know your facts within 10, you also know them within 100. So you can see here, 10 take away 4 equals 6. It's the same as 100 take away 40 equals 60. And you can see that link in that pattern. What we also do is we try to use different stories and put the maths into a context that the children can relate to and understand it better, more easily. So a ride at a fun fair had 10 seats in each carriage. You have to fill up the whole carriage before children can get into a new one. First, there are 7 children in the first carriage, then 5 more get on. How many children are there altogether? So this is really the first step of teaching the children how to bridge the 10, and we're doing it really in a really clear context. We're going to get them to use the concrete tens frame so they can do it alongside us, and they can see it pictorially on the board, and we go along, we do it together. So first there are 7 children, so you can see I've coloured in 7 dots, and they can do that with their tens frame as well. So I've got the 7 there, and then 5 more get on. So you need 2 sets to do this when you're bridging 10. So then you can see, I'll just show it mainly on the board now. So you can see that we have to fill in the first 10 to begin with. So we're making that number 1 to 10. We know that 7 add 3 equals 10, and then you've just got the 2 more. And we can confidently know that 10 add 2 equals 12. You can say it another way, we show it like this as well. So we use part wholes all the time in our maths to really so the children can really understand, and particularly when we're partitioning. So we know that 7 add 5 is what we're trying to do, but we're going to break down the 5. We're partitioning the 5 into the 3 and the 2, because the 3 goes with the 7 to equal 10, as you can see here, and then you just have to add the 10, add the 2 equals 12. We also use a lot of STEM sentences in our maths to really help the children articulate what they're doing, rather than saying, I just know the answer. So here, this is an example, we will all say it together. First, I partitioned the 5. The parts were 3 and 2. Then 7 add 3 equals 10. Then 10 add 2 is equal to 12. So we will repeat that all together, so the children are really confident with that. And we will do it in lots of different examples. So it wouldn't just be the first time they saw it, and then they would have a chance to apply it as well. In year 2, we really try and do a ping pong style of teaching, which has come from Shanghai. So we often do a review section of the lesson, and which is looking about what we did last lesson, but it's rather than just talking about it, they're actually having to do a quick activity normally on their whiteboards with a partner, so that they can really remember what they did last lesson. And because we do it in such small steps, then they know, oh, I did that last lesson, this is going to help me with this lesson. And then we also do warm-ups with our fluency, and then we start the lesson and we go through different slides, and often we stop and start. So then I say something, then they have a go at it, and then they have a go in their books, and then we come back together. So we're always feeding back to each other, and they're always having an opportunity to discuss it with their partners and discuss it with their teacher in a classroom setting, and it works really well. So yeah, I'm really pleased with that. So then we, like I said before, we use part wholes all the time, and we know that a part add another part is equal to the whole. The whole take away a part leaves us with the other part. So we use that all the time. It's particularly helpful for children when we're subtracting, that they know they always start with the whole, and when we're taking away to find a part. You can see here that we're always thinking about fact families all the time, to see those patterns and those links between number sentences, so they find the 2 addition sentences to go with the part but whole and the subtraction sentences as well. Now, I've given you an example here of a time when it's really a good challenge for children. So we've done a 20 cube challenge, really help them with showing them how they reason and problem solve, and showing it in different ways and how they can show and present their maths. So you collect 20 cubes. I would normally do this with you if you were in school, but I'll just explain it. So we collect 20 cubes, and you've got to make some equal groups. And when you made the equal groups, you've got to draw a picture, you've got to draw a bar model, so there's another form of a representation of part whole. You write a repeated addition sentence, and you write some times sentences. Again, with times, it's also commutative, so it will still have the same answer. It doesn't matter which way you put the 2 parts around. Also, you can see the equal sign. It doesn't matter where the equal sign goes in a number sentence, as long as both sides are balanced. We really try and teach that to the children early on, so they can see that they're not thrown if the equal sign is in a different place, and that they have a really strong understanding of what the equal sign actually means. So we would show them lots of ways of representing the same thing, and it says how many different equal groups can you make. So a lot of our challenges in class they don't just have one answer, or if they do have one answer, the children are expected to explain their answer. It's often like a true or false question or a prove it question. So or saying how many different ways you can do certain things. So this is a great example of that. You know, there isn't just one answer. They're really getting a chance to explore it and question their maths, and we're always asking them to explain it further, or saying why or how do you know that. So the children have a chance to really articulate what they've been doing using the STEM sentences. We show them lots of different ways of doing addition and subtraction and multiplication and division, so that they can choose which works best for them. It also shows them lots of different ways, so it's more of a chance for them to understand and deepen their knowledge of the concept. So at school in autumn term, we spent a lot of time looking at place value. Then we did a long focus on addition and subtraction, and then we did a little bit of money before Christmas. The reason we spend so long in addition and subtraction and number is that we really want to break it down into small steps for the children, and we're also reacting to what the children how the children are dealing with the lesson. So if they found it really tricky one day, we'll react to that, and we'll either change the lesson or repeat the lesson before we move on, so that the majority of the children are really confident. And if they haven't understood it slightly, we will try and do an intervention with them as quickly as we can, so that they've understood, ready for them before they have to move on to the next lesson. So we're trying. I've just shown you multiplication and division here as a challenge. We would normally be doing that now at school, but we wanted to wait till all the children were back in, so that we could really teach it step by step how we would teach it in school, because it's so important that the children have that number sense when they move on to the junior school, or whether they go next. So if you have any questions at all to ask me, please contact the school office, or if you want a more individual response to your child, then don't hesitate to ask your class teacher. I'm sure they would be more than willing to give you some tips and advice on how to support your child at home. Okay, bye for now.